Hey there, it's your cranky classmate here, and today we're going to be going over this AP Calculus Unit 7 Differential Equation review for AP Calculus A, B, and BC. So question number 1 here, we have the differential equation dy dx equals 2 times y minus 1 squared over square root x. We have a sketch of the field for a differential equation, and we want to find out if this slope field represents this differential equation of dy dx. And we want a reason to go along with that answer. So in order to solve this question, we will actually create a table for different values of x, y, and dy dx. Now, I see that at y equals 1, it seems like the slope is pretty much 0. So I'll choose a point y equals 1 and x equals 4 and find out what dy dx is at that point. Now, we have 2 times 1 minus 1 squared divided by square root 4. This is equal to 2 times 0 divided by 2, which is just equal to 0. So that point checks out. Now, let's see a point above that. So let's choose y equals 2, for example. Let's also choose x equals 4. And let's find dy dx at that point. So we have 2 times 2 minus 1 squared divided by square root 4. Now, this becomes 2 times 1 divided by 2, which is just equal to 1. So at the point 4, 2, which is this point right here, the slope should be positive 1. But it's negative, which means that this slope field cannot represent this differential equation. So part B here, we have let y equals f of x be the particular solution to the differential equation with the initial condition f of 1 equals 2. Write an equation for the line tangent to the graph of f at the point 1, 2. Now, to solve this, since it's asking for the line tangent to the graph at the point 1, 2, we actually need to use point slope formula, which, if you remember, is y minus y1 equals the slope times x minus x1. Now, the first step to solving this is figuring out what is the slope at the point 1, 2. So dy dx equals 2 times, and y equals 2, so 2 minus 1 squared, divided by square root x, which is just 1. Now, this becomes 2 times 1 squared over 1, which is just equal to 2. So our point slope formula becomes y minus, and we were given what y1 and x1 are. We can just use the point 1, 2. So y minus 2 equals 2 times x minus 1. And this is our answer. Now, part C here, we have find the particular solution y equals f of x to the differential equation with the initial condition f of 1 equals 2. Now, for this, we're going to need the equation for dy dx, so I'll rewrite that here. Dy dx equals 2 times y minus 1 squared divided by square root of x. So to solve this, we need to use separation of variables, which, if you remember, is we need to get all the y's and the dy's on one side of the equation, and we need to get all the dx's and the x's on the other side of the equation. So to do that, let's divide by y minus 1 squared on both sides, and then multiply by dx. So 2 dx over square root x. From here, we need to integrate both sides, and this will give us minus 1 over y minus 1 equals 4 root x. And since we're integrating without bounds, we can't forget our plus c. From here, let's solve for y. So we get negative 1 over 4 square root x plus c. That's equal to y minus 1. Now, that's good enough for now. Let's plug in our initial condition, which was, remember, f of 1 equals 2. So if we plug in y equals 2, that gives us 2 minus 1, which is just 1, equals negative 1 divided by 4 times square root 1 plus c. So 1 equals negative 1 over 4 plus c. Now solving for c here, we get 4 plus c equals negative 1 if we just multiply this to both sides, and c equals negative 5. Cool. Now it was asking for what y equals f of x was, so all we need to do is plug in negative 5 back into this equation and then solve for y. So this becomes negative 1 divided by 4 root x, and c was negative 5, so minus 5. And I'll just go ahead and add this 1 to both sides, so plus 1 equals y. And that is our answer. So I hope this FRQ was helpful, and now let's move on to a practice MCQ section.
Yo, this is a different cranky classmate. So let's look at problem number 2. So this is a classic differential equations question. I've seen these over my 20 years of experience, and it's a really common question on the AP exam, so you're going to want to know this. So the first thing we're going to do is multiply to both sides. So we're going to get 1 over y dy equals 1 over 2 dx. From here, we're going to integrate both sides, and we're going to get ln, absolute value of y, equals 1 over 2 x plus c. So what is ln of y? So that's the same as log e to the y, and that equals 1 over 2x plus c. So that means y equals e to the power of 1 over 2x plus c. But if we look at our answer choices over here, none of the answer choices actually match our answer. So what are we going to do? So we are going to see how we can rewrite this equation. So this is the same thing as e to the 1 over 2x times e to the c. And this e to the c, let's always remember that e is a number and c is also just a number. So this is basically a constant. So we can rewrite this as y equals big C. I'm just calling e to the c big C, and then e to the 1 over 2x. And if we look back to our answer choices, that matches answer choice D. Okay, number 3. This is another classic problem that I've seen over my 30 years of experience. So let's think back to our formula sheet. So for exponential growth, the differential equation is going to be dy dt equals ky. So what is our k in this problem? So our k is going to be 0.4, right there. And after we integrate this stuff and get an actual equation, we are going to get y equals e to the kt. So let's plug in some values. So y equals, and let's always remember that before an exponential equation, we always have to include our initial value, which is 1,000. So we're going to put 1,000 right there, and then e to the k, which is 0.4 as we found earlier, and our t value is going to be 8 right there. And I plug that into my calculator, do a little bit of buffoonery, and we are going to get answer choice C. Okay, moving on. Question 4. So this is another classic MCQ Calc BC question that I've seen a lot over my 40 years of experience. So this is an Euler's method question. So what is our equation for Euler's method? So it's going to be y mu equals y old plus change in x times slope. So what is our slope for our initial condition? So dy dx evaluated at 0, 1. So let's see, that equals 1. So for our first step in our Euler method, it's going to be 2 steps. So we're going from 0 to 1. So that means we are going to take each step as 0.5. So that is our change in x for each step. So that means our first step value for y1 equals 1, which is our initial y value, plus 0.5, which is our step value, and multiplied by the slope, which is this, which equals 1.5. So from here, we're going to repeat the same process. So our step size stays the same, so y2, and this is going to be our final step. So this is going to be y old, as we can see in the equation here. So that's going to be 1.5. So 1.5 right there. The step size stays the same. And what is our slope with our new y1 and x1? So dy dx evaluated at 0.5, since we moved our x value up by 0.5, and 1.5, which is right here. And let's see, what does that equal? That equals 2.5. So we're going to plug this into over here. So that is our slope. And if we calculate y2, which is our approximation of f of 1, it's going to be approximately 2.75. So if we look at our answer choices, that is or answer choice C. All right, question number 5. So another question, this is a classic question that I've seen a lot over my 70 years of experience. This is something that's very common on the AP Calculus exam. So let's think back to our formula sheet. So one of the equations on there is dp over dt equals kp times L minus P. So obviously the equation we have right here, it doesn't look much like the equation we have here. So how can we rewrite it to match this equation? So what I would do is I would do df divided by dt equals, so I'm just going to take out a common factor of 3f. So 3f right there, 4,000 minus f. So now we've rewritten it into a form that we can actually use. So as we can see, we have our k value right there, p value right there, l value right there, and another p value right there. So what is the fastest increase, or for what value of f is the number of fish increasing the fastest? So let's think back to our formula chart. So on our formula chart, the inflection point of this logistic growth is the fastest part where the number of fish is going to be increasing. So it's going to be right around here. This is L over 2. So what is L? So as we can see here, L is going to be 4,000. So that means 4,000 is L. So L over 2 equals 4,000 divided by 2, which equals 2,000.